Good afternoon, everyone. So here we're going to find the equation of the tangent line to the curve y is equal to 4x times the sine squared of 2x, specifically at the point pi over 2 comma y. Now we'll have to solve for that y coordinate if we want it, but that'll be pretty straightforward since we know how y is related to x, right? So if we're looking for the equation of a tangent line, we know that any line has the form y is equal to mx plus b, right? Now, what the derivative, what dy dx provides us with, is the slope of that line, right? So let's start off by doing that. Let's find our dy dx. So if we differentiate y, we have 4x times sine squared of 2x, right? Those are kind of like two separate functions we can use the product rule with. So I'll start off by doing the derivative of 4x, namely just 4 times sine squared of 2x plus 4x times the derivative of that second part. Now, we have a trig function raised to an exponent of 2. So the power rule, the 2 multiplies out front, and the exponent drops down by 1. So we have 2 sine of 2x times the chain rule demands that we multiply this by the derivative of sine of 2x, which is, of course, cos of 2x. And then again, by the chain rule, times the derivative of what's inside of the bracket, what we're taking sine squared of, and the derivative of 2x is 2. So times 2 at the very end. And now we can try to simplify this a little bit. So our dy dx, again, this is the slope. This will provide us with the slope of our tangent line, right? The instantaneous rate of change, which is what a slope really is, right, for that specific point on the curve. So simplifying this out, we get 4 sine squared 2x plus 4x times 2 is 16x sine 2x cos 2x. And now we could probably use the double angle identity, right? Since we know that sine of 2x is equal to 2 cos, sine of 2x is equal to 2 sine x cos x. We could extend that by a factor of 2, and now that the sine of 4x is equal to 2 sine 2x cos 2x. And if you'd like to use that to simplify this term a little bit, you could do that. I just don't think it's really worth the effort that it requires, so I'm gonna let it go. But again, go ahead if you feel like it. So let's simplify this down a little bit. Actually, maybe we can just leave it like that. I mean, we could factor. Yeah, let's factor it. So we have dy dx is, both terms have a factor of 4 sine 2x, right? So let's factor that out. So we have 4 sine 2x times sine 2x plus 4x times cos of 2x, right? That might make our lives a little bit easier. Now we have our dy dx, right? Our general derivative, our general equation to get the slope of the tangent line to the curve at any specific point. So if we're looking at the point pi over 2 and y, we can get the y coordinate fairly quickly by just plugging in pi over 2 in for x. Let's go ahead and do that. So y is equal to 4 times pi over 2 times the squared sine of 2 times pi over 2, right? So y is 4 times pi over 2, that is 2 pi, times the sine squared of 2 times pi over 2 is just pi, which means that y is equal to 2 pi times the sine of pi. So sine is our y coordinate, so that is 0. So that is telling us that y is equal to 0 at that point. So we're looking at the point pi over 2, comma 0 on this curve. So at pi over 2 and 0, dy dx, again, the slope of the tangent line to the curve at that very specific point, the instantaneous rate of change, is equal to, let's plug in that x value into dy dx. So we'll have 4 sine of 2 times pi over 2 times sine of 2 times pi over 2 plus 4 pi over 2 cos of 2 times pi over 2. We're getting towards the end here. So dy dx is equal to 4 sine of pi. Sine of pi is 0. So that's easy. Oh, okay. Sine of pi is 0. That's 4 times 0, which means we're multiplying everything by 0. Well, which means we have, oh, that's interesting. Which means we have a critical point at this point. We'll get into that later. Let's just finish this off. So sine of pi, again, is 0 plus 4 times pi over 2 is 2 pi times cos of pi, which would be -1. But again, 4 times 0 times all of that means that we have dy dx is equal to 0 times anything is of course just 0, right? So that means that our line y to the next plus b is going to be y is equal to our slope m, right? In slope-intercept form is 0. So we have 0x plus b, right? So if we plug in the coordinates of the one point that we know that line is going to pass through, because it's tangent to the curve at that specific point, right? It's going to graze the curve and touch the point at pi over 2 and 0. So we can use those x and y coordinates to solve for b, the y-intercept that makes that line a unique line, right? So if we go ahead and plug in pi over 2 in for x and 0 in for y, we get that 0 is equal to 0 times pi over 2 plus b, which means that b is equal to 0. So this is not a very interesting line. We get the line y is equal to 0 as our tangent line to the curve. Y is equal to 4x times sine squared of 2x at the point pi over 2 and y. Hope this helps. Thanks for watching.